Hello everyone, good evening. Yes, welcome for the next session. Uh, so we are in the midst of discussing a set of very relevant and interesting questions, 150 must do questions. So if you have been a part of this, you know that what we are doing, right? We are looking at the most, I would say, expected kind of problems or the concepts which have been tried and tested, along with a lot of questions which bring in some new elements, because we know that every year cat does throw us some very innovative problems. So we are trying to test ourselves to the hilt, I would say. That's the idea. So I hope all of us are ready, and to look at a question, a set of mixed math questions uh, in quant, right? Let's start with the session. So let me set the agenda that all of us are going to solve, right, as we are taking along the questions, and it's a race. Okay, so I'll give you maybe a few seconds to just absorb the question, and then you try it. While I'm trying to solve, you try to outbeat me. So the idea is who can do it fast, right? So I'll declare the names of all those people who can get the answers quick than me, right? So beat me, that is the idea, right? Okay, so people, let's start. Now, OpenCDC 3 is something that you should look up to if you are preparing. It's the real deal. The CDC mocks are designed to give you the actual feel and simulation of the exam. So I think the dates, are, I think, just nearing. So grab it, the opportunity, right, to take it at a center near you, and let's see how it goes for you. All right, so I hope you would look up to this, right? Okay, so with that, let's start. Here we go. Okay, so look at this one. I'll give you a minute to try, and then we'll discuss. Okay, let's see, people. So I've kept the first question something that should be a cakewalk, I guess. So I'm expecting you to give me the answers very soon. Now, so this question is about salary, the bring in efficiency in the sales department, wherein each employee is at the same pay scale. An entrepreneur reduces the workforce by one third and gives a 20% salary hike to the remaining employees. Hence, the salary bill on account of the sales staff has reduced by how much? So, the salary bill, can I say, to the entrepreneur is the product of the number of employees, let's say N, times of the pay given to them. It is given that each of them receives the same pay, right? So there is no variation in terms of that. So simply total salary is the number of employees N times the pay given to each of them. Now, so this was the initial salary, initial, right? So what will become the new salary based on the changes that have been done? So that will be equal to the new number of employees. So that has been reduced by one third. So the number of employees now become only two thirds of the initial. Now he does that and he gives a hike to the remaining. So the new payout to given to the remaining employees is 20% more, which is one fifth more. So the new pay is what? 1 plus 1/5 or 6/5, 6 by 5 times of the initial pay. So that is 6 by 5 P, right? So this is a new number of employees, two thirds. This is the new payout, 6 by 5 times. So overall, you can see the factor that is there. So 2 by 3 times 6 by 5 times of N into P. And this N into P is nothing but the initial salary. Thus the total salary that the entrepreneur has to give up, right? So 3 cancels and we get 4/5. So overall, the salary bill to the entrepreneur has still reduced by a factor of 1/5 or 20%. Hmm. So, right, quite straightforward, elementary problem, right, where we do this in the most efficient way by making use of the multiplying factor approach, right? Okay, so I think we are still warming up. People have not yet got alert, right? So please participate with me, right? I'm looking out for your responses. Let's see the next one. Here we go. So I'm taking it up right away, right? So try to beat me as we discuss. An apparel store. So profit and loss problem we have. An apparel store marks up its new arrivals by 125% and sells 20% of these items under fresh sale. That is no discount. After that, a flat 20% discount is offered. When 30% items get sold, and another 40% items are sold during the next phase, and a 40% discount is offered. So sequentially, the more lucrative offers are being made so that the items get sold off. The rest inventory is given away to an NGO and hence has a zero salvage value. So 20%, 30%, and 40%. So overall, 90% of the total inventory gets sold off. The remaining 10% is given away for free, right? What is the overall profit percentage made by the store? Hmm. So we have seen this kind of questions many times. In my sessions, you must have seen when the numbers are not there. So we are not given any monetary value for what was the cost price of the items, how many items were there. So we can make a suitable assumption for the same, right? So two things which are relevant here is the number of items, right, and the cost price. So let's assume both of them. I think 100 would be always a good number to start with, right? So if we assume that, let's say, the total number of items which are there to be sold is 100, and also the cost price of each of them is 100 rupees, right? So 100 into 100, the total cost for these items is 10,000 rupees. So we are working on this base value of 10,000 rupees as the total cost, and then let's see how much we can earn based on that, right? Okay, so the number of items are sold in phases. They are marked up by different percentages: markup percentage, discount percentage, and overall selling price, and finally the, you can say, revenue or the total selling price, right? So initially 20% of the items are sold at the whole markup price. The markup percentage is 125%. There is no discount, 0% discount. So 100 rupees, 125% markup makes it up to 225 rupees of selling price. So what is that in revenue terms? 20 items sold for 225 rupees. 225 into 20, 4500. 4500 rupees we get from here. A significant cost recovered, right? 10,000, 45% of cost recovered only from 20% of the items. But now we are going to sell at a discount, so the money will come in more at a gradual rate. Now a flat 20% discount is offered, so markup is still 125%. Discount is given as 20%. So what will become the selling price? So based on the 225 rupees mark price, so you will decrease it by 1/5. So 1/5 of 225 is 45. 225 minus 45, which is 180 rupees, is your mark, is your final selling price, and you're selling 30% of the items now, right? So 30 items are sold for a selling price of 180 rupees, right? And therefore 30 times 180, what does that give us? 5,400 bucks. Oh, very well done. So we are out of, I think, the cost, almost 9,900 rupees almost recovered. And then the next phase is going to be of the profiteering, right? 40% items. So 40 items are now sold during the next phase when a 40% discount is offered. 125% markup, 225 rupees selling price, 40% discount on that. 40% means 2/5 of 225. That would be 90. So 225 minus 90, which is 135 rupees, is the selling price. Now, right, 60% of 225, 135. So how much is the revenue now? 135 times 40. 135 into 2 is 270. 270 into 2 is 540. So it's 5,400 rupees once again. What do we have on the net? Finally, this grand total of revenue or the total selling price. 99,000 from here, and then another 54,000 makes up for 1,5,300 rupees, right? 115,300 rupees basically. So that's obviously a 53% overall profit percentage that has been achieved, right? So just I would say a routine problem, as long as you work with simple numbers and you get the idea that I have to add up the total revenue as we go along, right? It's a question on overall net profit, right? Okay, so these kind of, the idea is that when you see a lengthy question like this, don't get scared away from a lengthy question to read. Sometimes questions which are lengthy are easier. Sometimes questions which are one liners are very tricky, right? So therefore always look at the crux of the problem, understand what the question requires us to do. Is it something that we can understand what needs to be done? If you know what to do, then go ahead with it, isn't it? All right, people, still gearing up, not getting any response, please back up. Let's see the next one. Let's see if somebody can get this. Okay, so giving you a minute to try. So some people are asking me about recorded videos. Yes, they are available under the section of live recordings, but at the same time, the idea of these live sessions is that we discuss while we are together, right? So let's see if somebody can get this. I'm giving you a minute. Yes, this is doable. That's the point, Harry. Lengthy is not always difficult and not scary. Thank you for putting that out, Harry. I think the point is, once you read a question, does your mind get activated to understand what needs to be done? If that happens, you should go for it, regardless of the length of the question. That's my take on it, right? With my experience, I would say uh, difficulty of a question is not determined by its length. The two are quite unrelated factors. All right, so I think let's discuss, people, and do let me know if you're getting this. Now, the time taken by Raman and Bimal to finish a work. So it's about time and work, and the time taken is, some comparison is being made on the time taken. In time and work questions, the relationship between time and rate is always inverse to each other, right? So I will use the ratio approach or the variation approach on time and work. Uh, so consider the scenario of Raman and Bimal working together versus Raman working alone. That is being compared. So Raman and Bimal working together versus Raman alone, the time taken by them to work together is 25% less than that for Raman alone. 25% is 1/4. So it's 1/4 less. So the time taken by them together is 1 minus 1/4 of 3 or 3/4 of the time taken by Raman working alone. Or simply put, this ratio is 3:4 of time. So the ratio of the rate is the inverse ratio of 4:3. So 4:3 is the inverse ratio when they are working together versus when Raman working alone. It means that if I define the Raman's rate as 3, because I can see the ratio is 4:3. So if Raman's rate is 3 units, then Raman plus Bimal's rate is 4 units, means Bimal's rate is 1 unit, right? So we can assume these numbers for the rate from the ratio, right? If Bimal works at twice his normal rate, then the time taken to finish the same work when working together further reduces by how much? Now, something is changing up, right? So these are the initial values, you can say Raman and Bimal initially, right? Bimal's new rate is now 2 units instead of 1 unit. He's doubling his rate of work. Bimal's new rate is 2. So now consider the two scenarios of Raman and Bimal initially versus Raman and Bimal, the new scenario in which Bimal's rate is 2. So the total rate of Raman and Bimal now becomes actually 3 plus 2, which is 5. So now we are focused on these two scenarios. Raman and Bimal initially 4 units of work could be done. Now 5 units of work could be done, right? Eventually the question is asking us to relate the time taken to finish the same work further reduces by how much, right? So again, coming back to the same ratio approach, that rate and time are inversely proportional. So if rate is in the ratio 4:5, so the time taken is in the ratio of 5:4. Raman Bimal initially time taken was 5. Now the time taken is 4 in the ratio terms. So that's a decrease of simply 1/5, right? Maybe this was 50 days, now it is 40 days. In ratio terms, that's a decrease of 1/5 or 20%, right? So time taken has further reduced by a factor of 1/5 or 20%, right? Ratio approach, one of the most powerful techniques, right? No need for variables, equations, just working on ratio gives us the answer in a matter of a few seconds, right? So people who are comfortable or aware with all the with the way to use the ratio approach, this is doable in, I would say, 45 seconds, 1 minute time frame easily, right? So the idea in arithmetic throughout that you have been seeing is how to avoid variables, how to avoid equations, right? And the ratio approach is the most wonderful technique. All right. Okay. Right. People, next one, question 4, geometry, triangle, polygon. Again, I'll give you a minute to digest this and start trying. Okay, fine. Let's see. Regular polygon. Using the vertices of a regular polygon, a triangle is drawn which shares 2 of its sides with the polygon itself. Obviously, you must have realized the objective of the question is to figure out how many sides does this regular polygon have. From this given information, that the area of this triangle is given to be 1/4 of the area of the square whose side length is the same as the side of the polygon. There is a regular polygon. We don't know how many sides does this have, so we cannot complete it. So there is no figure that we can draw as such completely, but it's going like this. And the idea is that a triangle which is having 2 sides common with the polygon must have those sides as consecutive ones. For obviously those 2 sides cannot be located in 2 different places, right? So something like this, let's say this point over here and this point over here, let's say if I join them, then I form this triangle which is having 2 sides common with the polygon, right? Now, if let's say A is the side length of this regular polygon, then the area of this triangle is given as simply what? 1/4 of A square, because the area of a square having side length as same as that of the polygon will be A square. So the area of this triangle is going to be 1/4 of that. So the area therefore of this triangle having two sides common, is A square by 4. Now we have to use this given information to decode how many sides does this polygon have. Interesting. Now look at this triangle in which we know two adjacent sides are equal. It's an isosceles triangle, right? And what else? How can we write how should we write the area of this formula in such a way that the number of sides can be decoded? That's a key thought point. I mean, that's the key thing that we have to understand. What are the formulas for the area of a triangle that we know? We know Heron's formula, but we don't know the third side that we can apply that. We know half base into height, but on any particular base, we don't know the height. Any other formula that we know which is useful over here? There's one more formula for the area of a triangle. See, there are many formulas for the area of a triangle. Half base into height, not useful over here. Heron's formula, not useful over here. What is useful over here is half AB sine C. The area of a triangle is given as half the product of any two adjacent sides into the sine theta trigonometric function sine theta into the sine of the included angle, right? So the area of the triangle, therefore, we can write, if this angle is theta over here, this angle, then half into A into sine theta. So half A square sine theta is A square by 4. So we're going to get this value of sine theta from here, right? A square cancels, 2 factor cancels, and we get that sine theta is half. Right? A square cancels, sine theta is what? Half. So sine theta is half for what value of angle theta? If my knowledge serves me correct, 30 degree. Now, the sad part is 30 degree can never be the internal angle of any regular polygon. Because the internal angle of a regular polygon is given as 180 minus 360 by n, where n is the number of sides. For n equal to 3, which is the minimum possible number of sides, this angle works out to be 60 degree, equilateral triangle. As we keep on increasing the number of sides, the angle only keeps on increasing ahead and ahead after 60 degree and beyond. For square, it will be 90 degree. For pentagon, it's 108. For hexagon, it's 120. For octagon, it's 135. It keeps on increasing. So how can the internal angle ever be 30 degree? Impossible. But sine theta is half. So what theta is there? So little bit. See, this question is very craftily designed, right? It very beautifully is actually asking you the knowledge of trigonometry. Sine theta is half for not only 30 degree, but also for the supplementary angle, which is 150 degree. Because it's a trigonometric relationship that sine theta is always the same as sine of 180 minus theta, right? So sine 10 degree, let's say, is the same as sine 170 degree. Sine 45 degree is the same as sine 135 degree. Sine 30 degree, therefore, is also the same as sine 150 degree. Therefore, the required value of the angle theta over here is 150 degree, which makes sense. 30 degree does not make sense. 150 degree makes sense. Hence, 180 minus 30 is 150. So this 360 by n, can I say, is basically 30. Or the n is coming to be what? 360 by 30, 12. It's a dodecagon. It's a 12-sided regular polygon. Now, the answer is not the value of the number of sides. The answer is the next step. How many diagonals does this polygon have? Now, so the next thing is a little bit of PNC. How many diagonals does a regular polygon have? Right? From any two vertices, we can select any, from the n vertices, we can select any two vertices, join them, and we can get a line. NC2 or n into n minus 1 by 2 is the number of sides. I mean, the number of, you can say, just the way we can join any two sides, any two vertices, right? Now these NC2 number of lines will be diagonals, plus joining two consecutive vertices will give me side. So I don't have to count side. So there are n sides to be obtained from the n vertices. So minus n. NC2 minus n, or n into n minus 3 by 2. This is the standard formula for the number of diagonals of any polygon. So therefore, that for n equal to 12, we can find 12 n into 12 minus 3, 9 by 2, which is 9 into 6, 54. So there are 54 diagonals in this regular polygon. All right. So formula for the area of a triangle, trigonometry, sine theta is half, diagonals. So it's a multi-layered question, right? Step by step, asking, peeling multiple layers of concepts. It's not just actually a question of geometry. It's also a question of counting. It's also a question of trigonometry, right? That is how multiple concepts, you can see, can be thrown up all together, right? You miss one link, you miss the question, right? So I hope that uh, at least this is making sense. I mean, if there are any doubts, do let me know, right? I can clarify once again. Yes, clear, everyone? Okay. Quite a lengthy question. Linear equations. Again, lengthy is not necessarily difficult. Let's jump in. So solve with me, people, and let me know if you're getting this. Okay, buck up, buck up, buck up. You can do this. Two airlines, X and Y, operating on the same route, each have some limit up to which they allow free luggage and charge after that. That happens typically if you have flown, you know that beyond a certain limit, you're charged for the extra luggage, right? Airline X allows 25% more free luggage than airline Y, but charges 25% more per kg beyond the limit. Okay, so airline X is little bit free. I mean, giving you more freedom in terms of, okay, you can take more weight free. But if you exceed that limit, the rate it charges is significantly higher than that of airline Y. So there is a trade-off between the two, right? Aryan with 40 kg luggage chooses airline X as it costs him 200 rupees less for excess luggage. But Shaurya with 50 kg chooses airline Y as it costs him 200 rupees less for excess luggage. Okay. So initially airline X would be more cost effective because it is giving you more cushion, you can carry more as free. But beyond some limit, airline Y would be more cost effective because its rate is less. So that is reflecting in what the way Aryan and Shaurya are choosing their airlines. For 60 kg luggage, airline X costs how much more than airline Y? Okay, let's get down to this. We have to take variables. We have to create equations. There is no two ways about that. So let's do that. Okay. Uh, so for airline X versus Y, the free luggage limit. So can I say 25% more means the ratio is what, 5:4, right? Airline X allows you to take 1/4 more. So it allows you to take 5/4 times more with respect to airline Y. So this ratio is 5:4 for the free luggage in kg, right? So if I take this as, let's say, 5W for weight, and this is 4W for weight. So I've taken one variable W. So 5:4 is the ratio, 5W, 4W. Then the rate in terms of rupees per kg is also in the ratio of 5:4, right? That the rate of airline X is 25% more. So let's say R for the rate, 5R and 4R. Now let's create the equations for this. First we come to area. For Arya, what about the 40 kg? So how much will Arya be charged on airline X, right? The rate into the X's weight. So the rate is 5W, sorry, 5R is the rate for airline X. And the excess weight is whatever is excess in against 5W. So into what, 40 the total weight minus the free limit, which is 5W, right? And Y, airline Y will charge 4R is the rate, and the excess weight is 40 minus 4W. Perfect. So what equation we can write over here? For Rn, he chooses airline X, it costs him 200 less. So X is costing him less, or Y is costing him 200 rupees more. So can I say for Arya, the Y minus X is 200 rupees is the equation we can write over here, right? So Y minus X would be how much? Y is basically 16. So expanding this, 160R minus 16RW and minus of X, which is minus of 14 to 5 200R plus this 5 into 5 25RW. So that is what 25 minus 16, so 9RW and minus of 40R. So this equation is equal to 200 is the first one, right? 9RW minus 400 minus 40R. So this is 40R is 200, right? Then we come for Shaurya. Okay, so for Shaurya, airline X would be, again, he's taking 50 kg, so it will be 5R the rate into the excess weight, which is 50 minus 5W. For Y, it will be 4R and into 50 minus 4W, right? So in this case, X is costing 200 rupees more, right? For Shaurya, airline Y costs 200 less. So this was for Arya. Now for Shaurya, so X minus Y this time is 200 rupees, the other way around, right? So X minus Y, quickly doing this, I guess we can do this in one go. So this would be 250R and minus 200R. So 50R, 250 R minus 200R, right? So 50R, right? And this is minus 25W plus 16W. Minus 25 plus 16, so minus 9RW. And that is 200. So these are the two equations that we have. We have to solve them. Simply, you can see by adding them, we are able to cancel 9RW, right? So adding these two equations, we cancel 9RW. We are left with 50R minus 40R, which is 10R equals 200 and 200, 400. Or simply the R is 40 rupees per kg. Okay, so this is therefore meaning, this implies basically that this 4R is, this is 160 rupees. This is 160 rupees. This is 200 rupees. For R is 40. So the rate for airline Y is 160 rupees per kg. For airline X, it's 200 rupees per kg. Also, we need to find the W, right? Put R equal to 40 back in any of the equations. Let's say the first one. So can we say that 9RW equals, from the first equation, 40R, which is 40 into 4, 40 into 40, 40R, 40 into 40 plus 200. This is 1600 plus 200, which is 1800. So 9 cancels. So this is 9 cancels 200. And R putting back as 40, we get W as 200 divided by 40, which is 5. So this variable is 5. So this free luggage allowance for airline Y is 4 into 5, 20 kg. And for airline X, it is 25 kg. So we have got our numbers. Now we can come down to 60 kg calculation, right? So let me just make some space over here, right? We have got this, we have solved this. Now we can calculate for our 60 kg. So for that, for 60 kg, what does airline X costs us? It will cost us the rate, which is 200 rupees per kg, into the excess luggage, which is 60 minus 25, 35. So this would cost us 7,000 bucks, right? And for airline Y, the rate is 160. And since the free luggage allowance is 20 kg, so 60 minus 20, which is 40 kg is the extra luggage. So 116 to 40, which is 6400. So airline X is costing us by an extra amount of 600 rupees. 7000 minus 6400, which is 600 rupees, right? So again, what was the objective of this question? Something that is clearly doable, but on the first, this should not be a question that you do in the first go. See, my objective in these sessions is to show you all the variety of questions. Okay, lengthy questions which are easy, lengthy questions which are difficult, short questions which are easy, short questions which are difficult, lengthy questions which are easy but take more time to solve, lengthy questions which are easy but take less time to solve. So we saw an lengthy question earlier, which was actually not time consuming. This is a lengthy question which is easy but time consuming. So this should be done not in the first go, right? It should be done in your second iteration, right? First you grab the easy ones which are actually doable and also don't take too much time. Then you come to those questions which are easy, but and you know that you can do them, but it will take time, maybe, so this is a question that cannot be done in 1 minute. It definitely requires patience. 3-4 minutes and go away, right? As quick, as much quick as you can be, you have to rigorously frame the equations, solve them, and then also you have to then come to the another calculation for the 60 kg, right? So we are building our muscle, for the exam, right? That how to think, how to choose the questions. You see, this exam is not just knowing maths. This exam is completely your decision making skills which are being tested, right? So thank you, Vinay. Do share with me your answers, Vinay, as soon as you get them. Don't shy away from sharing them. All right. Okay. So back up. Next one. Next one. Here we go. What do we have? Something on maxima and minima. Okay. So I'll give you a minute to try, and then we'll discuss. Okay. Let's get ahead. Let's get started. You have to maximize this fraction, which is x by y mod. You have to maximize x by y mod. To maximize any fraction, which is numerator by denominator, obviously, if you have to maximize x by y mod, then what you have to think about, it is mod x by mod y, effectively, right? So you have to maximize the numerator. The higher the numerator, the higher the value. You have to simultaneously minimize the denominator. The lower the denominator, the lower the value, right? Perfect. So there are two different objectives with two different variables. We have to just work on them one by one. With this, both of them, we are given some inequalities on them. So that means obviously the you can say the boundary values of the inequalities will typically give us the most optimum value that we have to choose and insert in the given expression, which is x by y mod. X square minus 16, the mod is less than equal to 9. The standard result from the inequality, which is mod x, is less than equal to a. The standard result of this is that x lies from minus a to plus a. That is the standard result of any such modulus inequality. Whatever is written in the mod, whether it is x or whatever it is. So with this, x square minus 16 in the mod less than equal to 9 basically translates to x square minus 16 should lie in the range of minus 9 to plus 9. Taking 16 on either sides of this double-sided inequality, so x square lies in the range of 16 minus 9, which is 7, up to 16 plus 9, which is 25. telling us clearly that mod x, which is the square root of x square. Remember, the square root of x square is not x, but it is always mod x. So taking the square root, we can say that mod x lies from root 7 to root 25, which is simply 5. Obviously, this choice is therefore 5. Clearly, no doubts about that. That's easily done. Now coming to this more trickier inequality with y, which is y plus 1 by y in the mod lying from in the range of in less than equal to 4.25. Okay, so what do we do? Effectively, so it is telling us that y plus 1 by y is in the range of minus to the plus of 4.25. So we can, we can think of the positive range for the time being, right? We let's ignore the negative range of y, because in any which way we are going to take the modulus of y. So I would just say just focus on the positive part of the inequality, which is that y plus 1 by y is less than equal to 4.25. Now just think about this, that what is the boundary value? The boundary value is that y plus 1 by y could be at the most 4.25. 4.25 can easily be written in the form of y plus 1 by y, because it is 4 plus 0.25, and 0.25 is indeed nothing but 1 by 4 itself. So can I say this is basically telling us that y plus 1 by y equals 4 plus 1 by 4, clearly telling us what are the boundary values of y which satisfy this inequality, which is y could be either 4 or another value, which is simply 1 by 4. Because y plus 1 by y equals 4 plus 1 by 4 can also be written as 1 by 4 plus 1 over 1 by 4, meaning y is either 4 or 1 by 4. 1 by 4 plus 1 over 1 by 4 is 4.25, agree? So since I'm interested in the lower value of y as a small value, why would I choose 4? I would rather choose 1 by 4. So with the minimum value being 1 by 4, the maximum value of this fraction is therefore 5 over 1 by 4, which is 20. Right? So, right? So the idea is whenever you have these inequalities and you're trying to maximize, you're trying to find the minimum or maximum value of some expression related to the given variables, typically the optimum values are obtained at the boundary values. The boundary values means equality. You see, in both the cases with x and y, we got the optimum value at the equality. X square minus 16 equals 9 happens at x equal to 5. Y plus 1 by y equal to 4.25 happens at both 4 and 1 by 4. 1 by 4 was our best choice. Right. All right. Next one. Interesting. Probability. Modern maths. People. Now you should be able to do this. Now this is really something that I want some answers now. It's high time. Giving you a minute again. Please try this. You should get this. Very doable by now. Okay, so I've given you enough time, people. Do let me know if you're getting this. Since the question is basically only focusing on A and B, right? So we are actually not required to uh, take into consideration the other four people actually, to be very honest. Probability is basically defined as favorable ways over total ways, right? So for both favorable and total, you can just ignore C, D, E, F. You can just focus on the fact that we have six chairs and just two people, A and B, are sitting on them. You don't really need to arrange all the six, to be very honest. Because by symmetry, all that matters is how where A and B are located, right? Do they have exactly two between people between them or not? So let's just A and B choose their seats in all the total ways, and then the favorable ways you can count. So the total ways is basically simply the ways for A and B to select their two seats, right? Which is simply 6C2. Select two seats from six seats, right? I'm not even doing into 2 factorial. I'm just selecting two seats. That's it. 6C2, 15. 6 into 5 by 2, right? In 15 ways, A and B can select their seats in amongst the six seats. 15 ways. Favorable ways. Favorable ways that A and B have exactly two people between them. So with the seats number from 1 to 6, I'm just writing the combination of seats which is favorable, which is making this happen. So first seat and then second, third, leave that, and then fourth seat, so that they have two people between them. And then just go one step ahead. So it could be 1 and 4, it could be 2 and 5, it could be 3 and 6, and that's all. So this is three ways. 3 by 15, 1 by 5, that's it. In three ways, they can choose two seats with exactly two people between them. In 15 ways total, they can select their two seats, 3 by 15 by 5. I think I gave you a lot of time. And the idea was, I mean, I think if you got stuck or you were not able to do, perhaps you were doing the counting of all the six people taken together. Not really required. Right? So always make your effort as don't get into territory where you're doing calculations which are not relevant, which are superfluous. That's the idea. All right. Okay. Ready for the next one? Let's see. Let's take this as the last problem for today's session. For how many positive integer values of x is the LCM of x plus 2 and 2x plus 5, a three-digit number? Right. LCM HCF question on numbers. So let me take this up because this question is going to use a little bit of imagination, I would say, right? It's not as straightforward as of a question. X plus 2 and 2x plus 5, the LCM of that needs to be a three-digit number. Now, one thing which you should be able to observe over here is that if I double the first number, x plus 2, I get 2x plus 4, which is just one less than the other number. A point to be noted. One concept on LCM about particularly numbers which are mutually prime, co-prime numbers, right? When two numbers are co-prime, for example, let's say 4 and 9, they're co-prime. 7 and 8, they're co-prime. 12 and 11, they're co-prime, right? 16 and 25, they're co-prime. Co-prime means HCF of two numbers is 1. When the HCF of two numbers is 1, means they're co-prime, then their LCM is simply their product, right? And we know that any two consecutive numbers are always co-prime. So this question actually requires you to think through deeply with regards to the given expression. Once you look at the fact that doubling the first number gives us the other number, you should say that if I double the first number, which is x plus 2, if I double it and 2x plus 4, so it is co-prime. It is always going to be co-prime. Co-prime means no common factors with 2x plus 5 for any positive integer values of x. For any positive integral values of x, 2x plus 4 and 2x plus 5 are always going to be co-prime. It means their LCM is simply their product. Now, however, our actual number, the first one is not 2x plus 4, it is half of that. Or it is simply, you can say that remove the factor of 2 from 2x plus 4. So 2x plus 4 is basically twice of x plus 4. Now, if 2x plus 4 is co-prime with 2x plus 5, then can I say that since 2x plus 5 is always an odd number, so x plus 4, which is obtained by removing the factor of 2 from 2x plus 4, is also going to be co-prime with 2x plus 5. Because in 2x plus 4, the factor of 2, which is taken away, is never going to be a factor of 2x plus 5. So can I not conclude, therefore, that x plus 4 and 2x plus 5 are also always co-prime? Always and always co-prime. Since 2x plus 4 and 2x plus 5 are always co-prime, 2, if I separate as a factor from 2x plus 4, I get 2 times of x plus 4. 2 can never be a factor in 2x plus 5 because 2x plus 5 is always an odd number. Hence, x plus 4 and 2x plus 5 must be co-prime. Hence, it means that the LCM of these two numbers is simply their product, which is x plus 2. Sorry, this is x plus 2 and 2x plus 5. So the question now reduces to the simple calculation that for how many positive integer values of x is this expression, which I have just written over here, a 3-digit number? This expression. We can now get this done, I guess, right? So let's do this quickly. For the subsequent values of x, let's call this L as the LCM equal to this. So let's start writing the values of this L, and for what range of values of x does this fall in the range of a 3-digit number? Let's start from some number like, let's say 4. I'm randomly picking. So 4 plus 2, 6 into 4 into 2, 8 plus 5, 13. This is 78. We are not in the range right now. 5. 5 plus 2, 7 into 5 to the 10 plus 5, 15. 15 into 7, 105. This is when we enter into the territory. So obviously 6, 7, 8 and so on, we will be in that territory. Now look at the options 12, 15, 16. So somewhere in that range, let's say we go 15 numbers ahead, and let's randomly calculate for 15 numbers ahead. I'm just picking around number 20. Let's see what happens. Okay. For 20, what do we get? 22 x plus 2 into 20 into 2, 40 plus 5, 45. 22 into 45 is 45 into 2, 90. 90 into 11, 990. I think we are bang on the limit. Because obviously the next number, the next calculation for 21 would obviously be going much ahead because we are just on the brink of 1000. So I think from 5 to 20 is the range that x can take, which is 16 numbers from 5 to 20. All right, so finishing with numbers, because yes, questions on numbers have been also coming in recent years. Okay, so this was I would say a mixed bag of concepts, questions, something that requires us to think through concepts which we are expecting. All right, so this is today's session. I hope to see you very soon with the next one. Right, so stay in touch, stay connected. Career Launcher mobile app is here. So if you are not aware on that, you can check it out. It is one of the many facets that you can get connected with CL. Right, it's available on both iOS as well as Android. So until next time, thank you so much. Thank you so much, and stay connected, stay in touch, and happy learning. Thank you, people. Thank you.